Welcome to This Explainer. Today, we're going to dive deep into the massive 2026 shift from simply prompting chatbots to actually managing autonomous AI systems. We are moving from a world where AI just gives us answers to a world where AI actively takes action on our behalf. And as you'll see, that shift brings an incredible amount of power, but it also creates a really complex web of new responsibilities.
Think about it. Generative AI? That was literally just the warm-up act. So let's dive right into this critical question, because giving AI the power to take action changes absolutely everything about how we work and how we govern our technology. The real transformation happens when the system doesn't just, draft an email or write a snippet of code, but actually send or deploys that code live right into a production environment.
Here is our roadmap for today's explainer. First, the agentic AI era. Then, fueling agents with data, followed by the multi-agent workforce, the risks of autonomy, global AI governance laws, and we'll wrap up with the human-in-the-loop solution. Starting with Section 1, the agentic AI era. Let's define exactly what we mean when we say the era of the chatbot is officially over.
The absolute magic word here is autonomy. Agentic AI refers to systems that act independently with minimal human intervention. They don't just sit there and execute a single command. Instead, they combine the total flexibility of large language models with the precision of traditional programming. They pursue complex goals, they adapt to completely unpredictable scenarios on the fly, and they solve multi-step problems.
It's a profound paradigm shift. Generative AI just generates text or code when you ask it to. It's essentially a really helpful assistant waiting for your instructions. Agentic AI, on the other hand, acts entirely on its own. So, for instance, instead of just suggesting a code fix to you, an agentic AI can read a terminal error, plan out a correction, run a test, and then retry entirely on its own if the test fails. It is a massive shift from simple creation to actual execution.
And hey, this isn't just hype. The numbers we're seeing in 2026 are frankly extraordinary. Engineers who are using command line interface agents, like Claude Code, are reporting a staggering 30% increase in how fast they ship code. We're talking hundreds of thousands of hours saved because these agents treat the terminal as their native environment, just reading errors and fixing them in continuous, autonomous loops.
Which brings us to Section 2, fueling agents with data. Now, what's really interesting here is how these agents retrieve the knowledge they need to pull this off without totally hallucinating.
The engine under the hood is Retrieval Augmented Generation, or RAG for short, and it works in 4 key stages. First, you have chunking, which breaks massive documents into small, digestible pieces. Next up is embedding, which translates those chunks into high-dimensional vectors. Then, retrieval fetches the most relevant pieces whenever a query happens. And finally, generation synthesizes those verified facts into a perfectly coherent answer. It effectively grounds the AI in absolute reality.
But RAG has evolved a ton recently, so we've moved way beyond the basics. We started with vector RAG for broad searches, right? Then we moved to graph RAG, which is fantastic for mapping out the relationships between specific entities. But to get the most accurate answers for autonomous agents today, systems are now utilizing hybrid RAG. This perfectly marries the broad sweep of a vector search with the highly structured relationships of a knowledge graph. It gives the agent the absolute best context possible.
But listen, here's the data anchor you absolutely must remember. Even with the best architecture in the world, stale data is toxic. Agents relying on old training data instead of live web data hallucinate 35% more frequently. If an agent is out there making a purchase or updating a core system, it cannot rely on data from last month. Having live data access isn't a neat feature anymore, it's an operational necessity.
Moving to Section 3, the multi-agent workforce. With the right real-time data fueling them, these agents aren't just working alone in a silo anymore. They're actually collaborating.
We are seeing the rapid rise of fully orchestrated multi-agent systems. Single agents are evolving into coordinated teams working in parallel. Just look at some real-world use cases. You've got Atlassian's Rovo acting as a literal AI teammate across your entire software stack. AMD is using intelligent agents in Vertex AI to massively accelerate finance forecasting, and Spotify built an internal tool called Honk, where their best developers are now just orchestrating AI agents in plain English via Slack rather than writing the lines of code themselves. They aren't just coding anymore, they're managing an AI workforce.
But this takes us to Section 4, the risks of autonomy. Because with all this incredible empowerment comes a really serious paradox. We cannot talk about the benefits without addressing what happens when things go wrong. Think about it this way. When an AI just gives you text, a hallucination is annoying. When an AI takes action, a hallucination is dangerous. Whether we're talking about context pollution in a coding environment degrading performance over time, or a healthcare forecasting model acting on bad data, the structural damage can be profound. Unchecked agent actions can inappropriately alter critical business operations, and this proves one vital point. Being helpful is definitely not the same as being safe.
Which brings us directly to Section 5, Global AI Governance Laws. Because, let's face it, self-regulation simply isn't enough anymore, and governments worldwide are stepping in.
Looking impartially at the legal realities facing businesses today, there is a clear global push for stringent governance. In the U.S., Executive Order 1449 focuses heavily on prioritizing cyber defense and setting up voluntary benchmarking for frontier models. Over in the UE, the AI Act mandates strict pre-market testing and demands active human oversight for high-risk applications. Meanwhile, China requires algorithm pre-approval and strict alignment with state regulations. Across the board, no matter where you look, audible oversight is now a legal requirement.
Finally, Section 6, the human-in-the-loop solution. So how do we actually resolve this autonomy paradox? How do we reap those 30% productivity gains while staying compliant and keeping everything secure?
The ultimate solution is operationalizing a human-in-the-loop or HITLIL infrastructure. Crucially, when developers utilize AI agent-building frameworks like LangGraph, they're now designing what we call plan and execute agents, and these are programmed with strict breakpoints. To make this work operationally, they deploy user interfaces using tools like Streamlit, so the agent pauses its workflow, presents its planned actions through a clean Streamlit review gate, and just waits. It literally cannot proceed until a human actively reviews the plan and explicitly clicks approve in the UI for any consequential decision.
I love this quote from a recent healthcare case study because it perfectly summarizes everything we've talked about in this explainer. It says, AI succeeds when it behaves like a well-governed clinical service, not a clever model. It's a total mindset shift. We have to treat agentic AI as a distinct governance event that requires deliberate, built-in human checkpoints. Just like a clinical service, reliability, safety, and oversight have to be paramount. So I'll leave you with this final thought. As you deploy these incredibly powerful autonomous agents into your own daily operations, are your guardrails strong enough? Do you have the infrastructure in place to ensure that no matter how capable the AI becomes, humans remain firmly in control? Thank you so much for joining me for this explainer, and I'll see you in the next one.